7, unit number 7, it's the financial analysis and budget planning. I will go direct to the investment appraisal. I need to know whether you can see the screen, please. Let me know whether you can see my screen. I have shared the Word document. Let me see whether you can see you are able to see the screen, please. Can you see the screen? Yes. Good. Yes, it is visible. I see. You say that it is visible. Good. So if you can see the screen, I want us to start. And I want us to start with the investment appraisal. I had checked my program longly. I thought that we are finishing tomorrow, but we also have next week. So we have 4 sessions remaining, including today. That means we'll even do more. I had initially thought that we are supposed to finish tomorrow, but even next week, we are still meeting. Good. So if you can see my screen, I want us to call it investment evaluation. Investment evaluation or appraisal. Investment evaluation, investment or project. Investment stroke project. Investment stroke project evaluation or the investment or project appraisal. When it comes to the investment appraisal, we have the investment appraisal techniques or project evaluation techniques. They are classified under 2 categories. There is that what we call the discounted cash flow methods, and there are those that are called non-discounted cash flow methods. The discounted cash flow methods and the non-discounted cash flow methods. And because I know you have done this, when you talk of the non-discounted cash flow methods, we say that the non-discounted do not consider the time value of money, and therefore there is no discounting or compounding of the cash flows. These methods are the PBP, the payback period. Let me call it PBP method, and the accounting rate of return or the ARR method. If you know what non-discounted cash flow methods are, can I have someone just post on the text box? Can you give me the discounted cash flow methods that you know? I need to see which discounted cash flow methods do you know? Just post so that I can prove to you that there are others that you don't know. I can see someone has written NPV, IRR, adjusted present value, that is APV. Continue. NPV, IRR, APV. Are there others? NPV. No, capital rationing is not an appraisal technique. Someone has said capital rationing. Capital rationing is not. I can see someone has written MIRR. MIRR is modified internal rate of return. Someone has written PV. No, there is no evaluation techniques called PV. There isn't. PV is not correct. Yeah, there is the one who says APBP. It is called the discounted PBP, discounted payback period. I believe you are referring to that. I'm yet to see. There are many. There are others. Modified internal rate of return, yes. Adjusted the adjusted PV, the IRR, the NPV, the discounted PBP. Which other? Yeah, I could tell that there are some that you don't know. There is a method called the extended NPV, and there is another one called the extended IRR, extended internal rate of return, and the extended net present value. It is good that I will take you through those ones, but I'm very, oh yeah, someone has said profitability index, PI is correct. PI is very correct. It is another method of project evaluation. So in addition to those ones that you have said, there is what you call the XNPV. XNPV is extended NPV, and there is the XIRR. It is the extended internal rate of return. Having said that, I want us to go back to our screen. We are saying that discounted cash flow methods or the discounted cash flow techniques, these methods account for the time value of money, recognizing that money received today is worth more than the money, same amount received in the future due to its potential earnings capacity. The methods that we use are the NPV, net present value, internal rate of return is IRR, the extended net present value, which is XNPV, extended internal rate of return is XIRR, modified internal rate of return is MIRR, discounted payback period, and the profitability index. These are the commonly used methods when it comes to the evaluation of projects. Let us start with payback period. We start with the non-discounted cash flow methods. Payback period. A payback period indicates the period of time that an investor will take to recover the money invested in a project. It is the period of time that from the project undertaken, how long it will take to recover the initial investment. I want us to have an example. An initial investment of Rwandan francs 50,000 with annual cash flow of 20,000. We have 20,000, Rwandan francs 15,000, Rwandan francs 10,000, and Rwandan francs 10,000 in years 1 to 4 respectively. That means year 1, we have 20. Year 2, we have 20. When you go to the year 2, we'll have the 20 plus 15 to make it 35. But remember, our initial capital was 50, meaning by the end of year 2, we will not have recovered the initial capital. Year 3, we have 35 plus 10 for year 3. It gives us 45, meaning by the end of the third year, we will not have recovered our initial investment of 50. The remaining amount needed is to make from 45, to make up the 50, we need 5,000. But in the fourth year, how much are we realizing in the fourth year? So we say that since year 4 cash flow is 10,000, it takes a portion of this year to recover the remaining 5,000. So we need to calculate, or in the calculation we say 3 full year plus the remaining amount. Let me put it this way. Let me put it correct. Let me show you how I'll put this. We say that we got this. The remaining amount is 5,000. We divide by the amount, the 10,000 in year 4. It tells us that this period is 3.5 years. Let me put it in a different way. If I got the years, I have my year 1, year 2, year 3, year 4, and year 4, like that. I have the cash flows. Let me give the cash flows. The cash flow for year 1 cash flow, let me put it as 2015-10. This is 2020, 15, and 10, 2015, This is for, we are told that cash flow is 20, 15, 10, 10. Year 4 is 10. Year 4 is equally 10. Let me have it this way, 10. If that is the case, then I want to give the last part, I give cumulative cash flow. The cumulative cash flows. I want to cumulate these cash flows to the end. So by the end of the first year, we will have realized 20. By the end of the second year, we will have realized 35. By the end of the third year, we will have realized 45. By the end of the fifth year, we will have realized 55, like that. At what point are we recovering our capital? So I can have the summary like this. I have my years. I got year 3. I will have initial capital, initial capital, and I have year 4 for us to understand it better. If that is the case, I will have cash flow, the cash flows. This one, in this year, I have, by the end of the third year, 45. By the initial capital gives me 50. And by the end of the fourth year, I have 55. That is a better way to go about it. And if this is the case, we can therefore say that the payback period is equal to 3 full years. If you can see the screen, 3 full years, we take the initial capital of 50,000 minus the cumulative to year 3, like that. Then I will divide by the year 4, 55, minus the year 3, 45. Cumulative to the end of year 3, like that. So if this is the case, then it means we can take that one. Let me have it something like that. That means we have 3 years, our PBP is equal to 3 years plus, we take 50 minus 45, that is 5, divide by 10. And this is equal to 3.5 years. 3.5 years. That is the way to go about the payback period. It is a non-discounted cash flow method because it doesn't put into consideration the time value of money. Then from there, we look at the advantages. One, it is simple to calculate and easy to understand, as you've seen. It provides an indication of the project liquidity and risk, as early cash flow are generally more certain. Then it focuses on cash flow, which are less susceptible to manipulation than accounting profit. Its disadvantage is that a major one is that it ignores the time value of money. It disregards the cash flows that occur after the PBP period. This can lead to rejection of a profitable or a viable long-term project. It disregards the cash flows after the PBP because we are only concerned at the time that the initial capital will be recovered. Then it doesn't provide a clear accept or reject rule without predetermined target, or in case there is no other project to compare with. That is PBP. I believe that one is something that you are familiar with. It is something that is direct. The other one, we talk of the accounting rate of return. There are so many schools of thought on the formula for accounting rate of return. You will find different argument for the same, but either way, I would say that they are acceptable because this is one of the method that is so subjective. It lacks objectivity in project evaluation. So we say that accounting rate of return is average accounting profit divided by the average initial investment multiplied by 100. Some will say that it is average accounting profit over invested capital without the average. Let's have an example. An initial investment of 100,000 with a scrap value of 20 and total profit before depreciation of Rwandan francs 140,000 over 4 years. In determining the accounting rate of return, step 1, calculate the depreciation because you are given the accounting profit before depreciation. Depreciation is initial investment. We minus the scrap value. Let me put the depreciation per annum. Depreciation per annum is equal to the initial investment divided by minus the scrap value divided by the economic life. Economic life. That will give us the depreciation per annum, like that. Depreciation per annum, that way. So the depreciation in our case here, we need to get, let me get the depreciation per annum, not total depreciation, per annum is equal to, this project has 4 years. So we divide by the 4 years. Let us divide by 4 years. Divide by 4, divide by 4, and as a result, we'll have a depreciation equal to 20,000 per annum, like that. That will give us the depreciation. I can have it that way. That is the depreciation per annum. I need to put that way. That way. That is the first step. Step number 2, calculate total accounting profit. That is, total accounting profit is equal to total profit before depreciation minus the total depreciation. Total accounting profit. When you go to the question, what are we told in the question? Profit before depreciation, an initial investment of 100 and scrap value of 20, and total profit before tax. Let me change this word total and use the word annual. Annual profit before depreciation of this much. So how much is the annual accounting profit? We said that calculate the annual accounting profit. Annual accounting profit. Our annual accounting profit, is equal to the annual profit before depreciation and tax minus the depreciation per annum. In our case here, I will change this one. Let me assume that, let me change this one so that I can make it a little better. If I say this, let me give this one 35. 35 looks better. Let me use 35 here. 35 minus the depreciation, which we found to be 20. The amount is 15. This is 15. 15, like that. Then calculate average accounting profit. Average accounting profit. Average annual profit is equal to, I will take the full amount, that is the total profit. Let me say that now, the total accounting profit divided by the economic life. And our average is, we got the amount. Here I will take this one. I had given it a different approach. So 4 years, this is the total the total is 4 times 4 multiplied by 15. This one you divide by 4 years. This is equal to Rwandan francs 15,000. We have equivalent profits per annum like that. Then determine the accounting rate of return, 15 divided by initial investment. That gives 15%. Some will argue that average investment is initial capital plus scrap value divided by 2. Some other will argue that you divide by the invested capital. So in case you see somewhere invested capital, know that it is the one that I have used. The invested capital, because we are determining the accounting profit based on what was invested. It is not a common thing in the exam. Even in reality, it is not a common one, but it is a method that is used in evaluating projects. We say that it is good for initial screening. Advantages: it is relatively simple to calculate and easy to understand. Consider the entire life of the project. Uses accounting profit, which is familiar to managers and shareholders. Disadvantage one, the main one, is that it ignores the time value of money. It uses the crude averaging method, assuming that all cash flow, all the performance will be average. Then it relies on accounting profit, which can be manipulated and doesn't present the actual cash flow or the shareholders' will. Then it has different definition. As I said, you see this, it has different definition, e.g. using average investment. Sometimes it can give the use of the investment. So it has that disadvantage. It is not one of the best methods to use. But I think that one is okay, and it is a good approach for that point. That one I don't need to discuss a lot. Let us go to the the NPV method, and I need to see whether someone has a question before I go to the business of the day. Someone says that we have deducted 1 year depreciation. I was suggesting to remove depreciation for 4 years. No, I used the cash flow for the accounting profit. Remember, if you read through that question at the start, we are talking of annual accounting profit. If you could look at this, we are talking of annual profit before depreciation is 35. So we cannot deduct from the total. I know where you come from. That is, I have given it per annum. So that would not be correct. Any other question? Anyone with a question before I proceed to the serious business? I need to see whether someone has a question on this other side. I don't see any question, so I'll assume that to this point we are together. Let us go to the discounted cash flow methods or the discounted cash flow techniques. And I want to explain this thing in a better way. Let me see what I'll do so that I can explain it in a little better way. Allow me to give an illustration that will explain. Illustration. We say that a 5 years project is expected to generate cash flows, I want you to remove your calculators as I write this. Is expected to generate cash flows as follows. Just remove your calculators. Years years. 1, 2, 3, 4, 5, 6. Let me call it a 6 years project. A 6 years project. 6 years project. Like that is expected to generate cash flows as follows. Cash flows. The cash flow 120 thousand. This one I give 150,000. Just a second. Just a second. For the interruption, I think we can continue. You look at this project. The cash flow in year 1 is 150. Let's give the second year, we give it 200. We give the third year, we can give it 250. Let me give it 250, like that. This is year 1, 2, 3, 4. I can also give the next one, I give it 300. That is 1, 2, 3, 4, 5. Let me add a 6th year. I can give it 340. Or let me give it 360. Like that. If that is the case, let me try to arrange it in the best way. Just the best way. Okay. Good. I think it is better that way. That's year 1, year 2, year 3, year 4, year 5, and year 6. Good, like that. Suppose we are investing the initial investment is, if I take this one, I'll take 6 years. I can assume that we are investing 720,000. The required rate of return is 12%. Now, let's look at it this way, from this perspective. Possibly, I want to ask you a question. Because of the current inflationary challenge in the global inflationary challenge, can someone tell me what is the base lending rate? What is the risk-free rate by the Central Bank of Rwanda? How much is Rwanda charging for the interest rate, the risk-free rate? Maybe someone can give me that. Rwanda, how much is it? Maybe you can post, you can write there. I need to see. How much is the risk-free rate by the Central Bank of Rwanda? Someone says it is 7%. The risk-free rate, the one by the Central Bank of Rwanda. Someone has written 7%. So another person has written 6.5%. Another one has written 6.5%. Let me see. 6.5. But I feel I don't I feel like I'm not. I disagree with you. I disagree with you. I'm on an assignment for the. I got the data for a good part of African countries. I am doing an assignment for the Central Bank of Malawi. We are trying to work out their fiscal policy, and their base lending rate is 16%. That is how things are in Malawi. They are at the hyperinflation economy. Kenya is at 9.5%. I will disagree with you 6.5. I don't think it is 6.5. 6.5, that one I think it is not true. Can you find out the facts? Because 6.5 is a super performing economy. That one, because the inflation in Rwanda is higher than Kenya. Inflation is very high in Rwanda compared to Kenya and Tanzania. So I don't understand how you would say that the interest rate issued by the central bank is 6.5. That one I doubt. Find out that information so that you can get the correct information. Okay, let's look at now what we have here. I will give the cash flows this way, cash flows. But let me ask the question. I want us to determine A, the NPV, B, PI, 3, IRR, 4, MIRR. What else do I need to give you? Yes, let us first determine that. I want to give you 5 minutes. You give me the net present value. 5 minutes, give me the net present value before I intervene. Give me the net present value based on the information that you see. The NPV. How much is the net present value? Someone is giving me 167.90. I can see one response of one. Can you see my Excel sheet? Can you see my screen? Good. If you can see my Excel sheet, I want to use Excel sheet so that I can move fast. Yes. 1, 2, 3, 4, 5, 6. These are the years. I want to confirm what you've determined. Cash flow, the cash flows. I had 120, I had 150, I had 210, I think. I had, how much was the other one? 150, oh, 200, 250. This was 200, 200. This one was 250. This one, the other one was how much? 300, 360. 300 and 360. Like that. I want to do the discounting rate. Discounting rate. The discounting rate is at 12%. 12%. So we say that year one is equal to 1.12. We make it power -1. This will give us the discounting rate for year one. And I'll go down to the last year, which is year 4. In an examination, always give 4 decimal places. 4 decimal places for the discounting rate. It is sound okay that way when you give it into 4 decimal places. Then when you come to the next column, we give the present value of cash inflows. Present value of cash inflows. Present value cash inflows. How do we get the present value? It is equal to the cash flows multiplied by the discounting factor, like that. And if that is the case, we need to determine for each of the periods. The final answer, you can give it in 2 decimal places, like that. Then from there, we talk of the total present value cash inflow. We take this is equal to the sum of this. This gives us the total present value of the cash inflow. Then from there, we less initial capital. Initial capital. The initial capital. Our initial capital, we say that the investment is 720,000, like that. How much is the NPV? It is equal to, we take the total present value minus the initial capital outlay, that way. If that is the case, we have the NPV and we can confidently say that our NPV is positive. This is a positive NPV, positive net present value, positive NPV, like that. I don't know whether that is what you had determined. Some people had sent the answer. Let me see what it was for those who had given. Let me see. What did you share? What did you send? Year 3 is 200, not 210. Yes, that year is cash flow is 200. Did I say 211 or 200? Let me check. 200. Oh yeah, this is 200,000. Good, that's correct. So when we get to that, I don't know what you people had given me. Okay, maybe I think I had lost your answer. There's someone who had given 175. Someone had given 175. Okay, I had seen 160, something like that. And that is the NPV. The NPV, we can therefore say that the net present value is equal to the total present value cash inflow, we minus the present value of cash outflow, present value of the cash outflow. And that is how we have determined the NPV here. Now I want to see the profitability index. Can someone give me the profitability index? Profitability index, please. Someone to give me the profitability index. Profitability index. PI. Can I see? Share the profitability index, compute the profitability index and share. Someone is giving 0.233. Let's see another one. Profitability index. 1.223. 1.223. I see 1.223 twice. I will give two formulas for profitability index. Profitability index. This one we call it the PI. We say that PI is equal to present value cash inflow, that is the total present value cash inflow, you divide by the present value cash outflow. Alternatively, we can say that PI is equal to the present, we say that it is 1 plus NPV divided by the present value cash outflow. That is the other way to determine the NPV. In this case, we are saying that, the profitability index. In this case, we can comfortably say that our present value cash inflow, or the profitability index is equal to 572.77. We divide by 720, like that. How much is it? It is equal to this divided by the initial capital outlay. That gives me 1.22. I can give it to 3 decimal places, 23. The other option could be it is equal to profitability index is equal to 1 plus the NPV. How much is our NPV? It is equal to 160, 572, 572.77 divided by the initial capital outlay, 720, like that. It should give us the same, equals 1 plus, we take the NPV divided by the initial capital outlay. It is giving us the same. So those are the two options of determining the profitability index. I don't know whether there is a question. If there is a question, I want to transfer this one to the Word document so that we can make things easier. Good. Any question? Any questions so far? I need to see whether anyone has a question. Any question, anyone with a question, anything that is not clear? I think everyone, we are reading from the same script. Good. Let us continue. I want us to give the internal rate of return. Internal rate of return. This is what we call the IRR. Now, for the IRR, or before we go to the IRR, we ought to have made a decision and say that since NPV is positive, since NPV is positive, accept the project. Accept the project. Then we say that since the profitability index is greater than 1, accept the project. Accept the project. That is the decision criteria. I know these things we are I'm just reminding you because they are things that you are familiar with. Now, internal rate of return. The internal rate of return is determined based on the type of the cash flows that are given. In case of the changing cash flows, we say that internal rate of return, or let me say that steps in determining the internal rate of return. Oh, sorry, I'm not sharing the Word document. Let me share the Word document so that we can move together. Sorry for that. Let me share the Word document. Good. I hope you can see it. See, look at my document. So steps in determining the internal rate of return. Number one, compute the IRR. Compute the NPV. Just let me format it well. We say that compute the NPV. That is step number 1. Step number 2, if the NPV is positive, rediscount the cash flows again, using a higher trial discounting rate, to get a negative NPV. Note the word trial. It is a trial rate. Number 3, in case the NPV in step 1 above is negative, rediscount the cash flows again using a lower trial discounting rate to get a positive NPV. So we are guided by note 1, by the first NPV. Compute the NPV. If the NPV is positive, use a higher trial discounting rate to get a negative NPV. But in case the NPV was negative, you are supposed to rediscount the cash flows again using a lower trial discounting rate. Then from there, interpolate the results. Interpolate the results to get the NPV, the IRR. How do we interpolate? We use the interpolation method. There are many methods. We can use the graph, but interpolation goes like this. Internal rate of return is equal to the lower rate, the lower rate. This one we add positive NPV minus zero. This one, then whatever you get, we will multiply by the lower, the higher rate minus lower rate. Then remember, we have to divide this part, this here, the positive NPV minus negative NPV. That is the point to be considered. Like that, I want to separate this one well, so that at least this is positive NPV. I will have to divide, let me have it divided like that. So that is the formula for the IRR. I will give this one, let me try to squeeze it for clarity and visibility. Let me have it like that. So we are saying that it is the lower rate plus positive NPV minus 0 over positive NPV minus the negative NPV. Whatever you get, you multiply by the higher rate minus the lower rate. I want us to go back to the question, to our question. We determine the IRR. We said that since the NPV at 12%, in this case, we say that NPV was equal to how much? Our NPV was how much? 160, 572. 160, 572. It was 160, 572.77. He said 572. Yeah, 572.77. Since the NPV at 12% is positive, rediscount the cash flows again using a lower, using a higher trial discounting rate, to get a negative NPV. Let us try what? Let us try 18%. Can someone give me the NPV of these cash flows using 18%? These cash flows. Can you give me the NPV using 18%? Someone to give me that using 18%, please. Give me the NPV at 18%. How much is the NPV? Okay, instead of 18%, use 20%. I think 18% might not give us the best answer. Use 20%. Please try using 20%. Don't say 18. Use 20%. Let's try 20% instead. Try 20%. 20%, 20%. These are the cash flows to be discounted. I have my cash flows here. Please determine the NPV. If you haven't determined it like this, it's this. There we go. It is negative 38,402.78. Now, can we determine the internal rate of return? The IRR is equal to, the ROA rate is 12%. This one we plus the positive NPV. Positive NPV was how much? We had a positive NPV. It was 160. This one, 160. Positive NPV is 160. There, minus 0, divide by, this is another positive, that, minus negative, so minus negative 402.78. If I could have it that way, then I will take it multiply by, the higher rate is 20%, minus the lower rate is 12%, like that. Yeah, I think that is the way it should be. Then from there, we put that way. How much is the internal rate of return? The IRR, please. Put that one on your calculators and give me the answer. The IRR is equal to IRR. I'm waiting for your answers. I'm checking what you are giving me. Someone says is 18.456. That's the first answer I get. Someone else? Someone else? 18.45, 18.455599. So I believe it is correct. The 18.456%. At IRR, we say that at IRR, NPV is equal to 0. That means if IRR is used to discount the cash flow, the NPV will be equal to 0. And therefore, we say that since our IRR is greater than the 12% cost of capital, it is greater than 12% cost of capital, except the project is viable. The project is viable. The project is viable. That is the other one. I want to explain using the same modified internal rate of return. Rate of return. We call it MIRR. MIRR is equal to the modified internal rate of return is equal to the nth root. Let me first put this one. Future value of cash inflows. Future value of cash inflows. We divide by the present value or initial capital. Let me use the word initial capital. Initial capital, that is the nth root. Whatever we get, we minus 1. Let me try to put this one in the very best way so that at least we can have it correct. Let me put it in a tabular format so that at least we can have it correct. Let me put it in a table that way. Good that way. I will do the nth root. The nth root. Just allow me to draw the root. The nth 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 root. Good. I think that is the way it should be. I want to put it because I know maybe someone is familiar with this one or not familiar with it. Like that. But this part we need to divide that way. So when we pick it from here, when I put it that way, you will not You will not forget. What does this mean? It means when you have a project, you invest and reinvest the cash flows up to the end of the project's economic life. When they are invested, they generate more returns, and that is how you get the future value. And I want to put it this way: years 1, 2, 3, 4, 5, 6. Then I'll have the cash flows, the cash flows. Or let me just do it on an Excel sheet so that I can move a little fast. You need to understand. Let me use the Excel sheet. Look at this sheet. If you can see the Excel sheet, I will just take these cash flows. I hope you can see the Excel sheet. I will have them here. These are my cash flows. And here I'll have the future value, future value interest factor at 12%. I am assuming that once we get the cash flows, we reinvest them at 12%. And this one is 1.12. Now, I want to explain something. Let me just expound it a little so that at least we can understand. I want us to get it very right. This one is equal to 1.12 power. I'll give it power because we are in year, at the end of year 1, we are left with 5 years. For 5 years, we will invest it for 5 years. This one, I will give it power 4 years, like that. We go reducing the years to the end. Let me make it that way. That is what you use to determine the present value, and as a result of that, we get the future values. How do we get these future values? We've said it is equal to 1.12 power. I put a bracket 6 years minus the year in question, like that. That is giving us the future value rate, like that. I can give it some 2 decimal places because we are determining the future values, and this is where we get the future value. So the future value is equal to the cash flows multiplied by the compounding factor. It is the compounding factor. We sum them up, and did I do this one right? Power 0. Oh, I did multiply. Did I multiply? This should be power. This should be power, not multiplication. That's an error. It's that way. Yeah, like that. So yes, like that. I need to get the future value. The future value, total future value. Let me call it total future value. Total future value, it is equal to the sum of this. That's the future value. Yeah, that is the future value. If someone has a question, I want to see whether someone has a question to that point, please. Ask a question before I proceed. Just ask a question. Anyone with a question? Anyone with a question? I cannot see any question. That tells me that we are all comfortable. Now, if this is the future value, I want to put it back to our Word document so that we can now put it in the formula. Let me put it in the Word document. I hope you can see the Word document. I will have it this way, like that. Good. That is it. And if that is the correct thing, we have the future value. The present value is the initial capital outlay, the modified internal rate of return. The modified internal rate of return, I want to put the figures in it. Let me have the figures in it here. The nth root, these are 6 years. The sixth root, we need to get the future value. My future value is 1,738,738. That is 738,094,094.506.506. We divide this one by the initial capital. Remember, our initial capital was 720. 720, like that. That way, that should give us our modified internal rate of return. I want you to compute it and give me the MIRR. MIRR is equal to, put that in your calculator. I believe it is clearly visible from your end. It should be clearly visible. Give me the modified internal rate of return, if you can see it from my screen. Or someone is requesting for explanation of the future value. Okay, first give me the MIRR. I will explain. Give me the MIRR. MIRR. Let me see the MIRR. For those who have determined, I can see 16%, 15.8, 15.85, 15821. It is 15.82, 15.82, 15.82, I think that is what we are getting from the majority. They are giving us 15.82. So if you can see my screen, that is the way to determine the modified internal rate of return. Its verdict is the same as the internal rate of return. Being greater than the cost of capital, the project is viable. So allow me to just borrow that statement up here. Since the modified internal rate of return, since the MIRR, since MIRR is greater than 12% cost of capital, the project is viable. That is the use of the modified internal rate of return. I don't know whether there is a question. There is someone who had asked about the determination of the future value. Is there any other question apart from that? Let me see. What was the question? Yeah, the future value. If you can see my screen, I want to explain that one again. I want to explain it again. When you get the cash flow in year one, 120,000, we say that the cash is not kept. It is invested or reinvested to earn more cash flows during the remaining life of the project. And because you are at the end of year one, you have year 2 to year 6, those are 5 years. The one you earn in year 2, you have year 3 to year 6, those are 4 years. We give the compounding rate, the rate that will give you the future value of the cash flows. That is what it means. We are giving the one at year 6. It is generated at the end of year 6, meaning you will not reinvest. Once you get the future value for each of the cash inflows, it will give you the total future value of the cash flows. That is what we call the reinvestment of the cash flows. I don't know whether that statement is clear. We've done the NPV profitability index, NPV profitability index. We have determined the IRR and modified internal rate of return. I want us to do the discounted PBP. Discounted PBP. Let us do the PBP. No, let me do the discounted. Discounted payback period, PBP. Allow me to shift to the Excel so that I can move fast. I move to Excel. Let me go to Excel sheet. I will use my original cash flows here, these ones. And this is how we determine the PBP. I'll put it there. Like that. I have the cash flows. I have the present value of the cash inflows. Here I have cumulative. Cumulative PVs. Cumulative PVs. Like that. The cumulative PVs. So this one is equal to, for year 1, for year 2, it is equal to this plus this, like that. We cumulate them that way. Our cash flows are accumulated that way. Then we can have a summary here. Summary. I got, where are we recovering the 720? It is between year 5. Here we have initial capital, and here I have year 6. Then I have the cash flows. The cash flow for year 5 is the cumulative cash flow in year 5. This one. The one for initial capital is 720. And the one for year 6 is this much. If that is the case, if we got that as the case, can someone determine for me the internal rate of return, the discounted PBP? Discounted PBP. We say that discounted PBP is equal to, we take 720, we minus 698, 185, 185.56, like that. We divide this by the 880. This is 880, 572.77, like that. Yeah, that way. Of course, we ought to have added. We are taking what? We are taking 5 plus. 5 plus. Let me put it that way. Please give me that. Give me the discounted PBP. Someone to give me the discounted PBP. I need to see the discounted PBP. There is none that is better than other. It is only a decision between IRR and MIRR. They are both good. It only depends on the assumption that you make. There is none that is better. The only thing is that MIRR try to resonate, but it doesn't give any advantage to any. It is only the assumption. You assume cash flows are not invested, the other one cash flows are invested. So the one asking which one is better between MIRR and IRR, there is none that is better than other. It depends on assumption. Number 2, IRR assume cash flows are kept. MIRR assume that cash flows are invested. They are invested. Okay, let's get the discounted PBP, please. Someone has posted 5.12 years. Discounted PBP. Someone else? Let's see. I'm waiting for your response. $5.12. Someone else has given 5.12 years. So let me assume that that is correct. and I'll put it here 5.12 years. Then I can come and pick it here and take it to our Word document. That is the discounted. I hope you can see my screen. This gives me the discounted PBP. The discounted PBP. Good. I want to ask you a question. I want you to look at these cash flows the way they are. Can you give me the PBP? Give me the PBP. If you can see my screen, I want you to give me the PBP. I just need the answer for the PBP. We have computed the discounted cash flow method. We have discounted the PBP. Can you give me the PBP? Give me the PBP. Someone is asking why we are not multiplying by 12 months. Oh, for that one, you may multiply, you may leave it like that. It is optional. You can multiply or leave it like that. So can you give me the PBP? 2 minutes, compute the PBP and give me the PBP. The PBP, who has computed 4 years? Someone give exactly 4 years. 4 years, 4 years, 4 years. That is what I see. Good. So if it is 4 years, I don't need to compute it. I'm assuming that we all understood and I have explained those methods. I want to give a brief explanation of what we call the extended NPV, extended net present value. We call it the XNPV. I will show it in Excel because this one you may not be tested in an exam because of its complication in computing. But I want to show you because it is the best method of evaluating projects. I repeat, it is of all the methods, XNPV and XIRR are the most realistic methods of evaluating projects. And I will explain it. Let me share an Excel sheet so that I can explain it in a way that you will understand. You may not be tested in an exam, but it is good to understand for reality. We say that the cash flows, when it comes to reality, to the real life, cash flows do not happen at the end of the year. They just happen. So we say that cash flow dates. First, can you confirm that you can see my screen? Please confirm that you can see my screen. The Excel sheet, confirm that you can see my Excel sheet so that when I'm explaining this one, it is a very important concept. Very important concept. Can you see my screen? Can you see my screen? Yeah, I see it is visible. I am sharing the Excel sheet and I want to give a brief argument. Just ignore the formula that I'm using to generate data. Just ignore this. I just want to generate data. Just don't bother yourself with this one. First, ignore this one. I will explain the data. You don't need. This is how an exam is set. If maybe I can put it that way, by generating data using a computer. I want to make it very brief. I want to make it very, very brief. Very, very brief. These are dates. Cash flows do not happen in a certain order, the way we assume when we are determining the NPV. They will just happen randomly. The cash flows happen randomly. In reality, cash flows happen randomly. So if a project was undertaken at the start of year 2025, I can have my cash flows here. This is 2025. I give it date 1 January, like that. This is let me put it correct. Yeah, let me give it that format. That format look good. January 2025, that is when we invest. The first cash flow happened in November. The next one, January 2026, May 2027, May 2027, June 2027, January 2028. There is no pattern the way we assume. That is the reality in life. Then cash flow. Let me assume cash flows again. Just ignore the way I'm determining it. I am assuming that my cash flows happened randomly, like that. These are my cash flows. They just happen randomly. It is not the way we assume in class. The reality is that cash flows will just occur. You wake up, make a sale. It is random. So I'm assuming that my cash flows happened like that. If that is the case, we need to get the present value, interest factor, or let me call it the discounting factor. Now, when you look at this discounting factor, it means that we are discounting the cash flow in the first period. Okay, let me make the first cash flow to be the cash flow, the investment. So let me put it this way. let me make the cash flow in year 0 to be the investment, and I will give it this way. I assume that I invested 8 million, like that. Or let me be a little reasonable. 5.4 million. I invested 5.4 million. 5.4 million, that is my investment. Initial capital outlay, I can make it a negative figure because it is an investment. And these are the cash flows. When discounting what we call the extended NPV, it is because we consider these dates. We don't assume that cash flow happened at the end. So how do we get this one? We'll say that this one is equal to, okay, let me put it this way so that at least it can be clearly understood. These are the cash flow dates, then years. Years, I'll say that years is equal to each year we minus year 0. Each year we minus this year 0 when we started, like that. We minus year 0. So this, okay, let me correct this. This one should be a general figure. Then I think I need to divide by 12 to know how many is, sorry. I want to make it as clear as possible. As clear as possible. What is this? Good. These are my years. These are the years. If you are to put the years based on the given dates, you say that this is the investment period. This one gives me how many periods? It is 2025. No. That one is this correct, really? Okay, just 1 minute. I make it correct. I need to have this one as 12 months. Yeah. Oh, okay. I divided with a long figure. I should have divided by, these are days. If I were to divide by, let me see. Yes, good. This is it. From this is year 0. Let me make it a little bigger for visibility. This is 1st January 2025 is year 0. 3rd November 2025 is 0.84 of an year. That 1st January the following year is 1.08 of an year. All the way to the very last point on 25th March 2030, it is 5.23 years from year 0. So if you were to determine the discounting factor, we'll say that this is equal to, let me assume that the discounting factor is 12%. 1.12 power negative this period here. The years, we use the years. Then I will drag them down to the end. I can give them 4 decimal places like this. 4 decimal places. So if I want to get the PV, I'll say that this is equal to the cash flow you multiply by the discounting factor, and when I bring them down, 5.4 million, yeah, then I bring them down. I will give this one to 2 decimal places so that it is stop looking so strange. Like that. When you look at this one, it gives me the discounting factor, the discounted cash flows, and when I come and sum them here, I get equals sum equals sum, like that. I will put them upward this way, close the bracket and enter. This is my NPV. This is my NPV. At the end, this is the extended, we call it the extended NPV. Extended net present value. This one is the XNPV. XNPV. That will give us the NPV, like that, the XNPV, and that is the way we make the decision under this model. Let me do this. I want to change my initial capital here to make it a little bigger. Let me make it 7 million. That one looks reasonable. Now, when you look at this one, this is the extended net present value. The difference between the other one is the other one, we are assuming that cash flows happen at the end of the year. That is the difference. Under the extended NPV, the cash flows are picked at the exact date that they occurred. I want to transfer this one to the Word document so that I can explain it from that end. I just wanted to use Excel for the computation. Let me put it here. Then I can explain it from here. Extended NPV. Extended NPV. I will put it this way. I'll say that XNPV captures the cash flows on the exact date that they occurred. Captures the cash flows on the exact date that they occurred. Consider the following. Consider the following. So I will use this one as a demonstration. I don't want to go into much details because the examiner cannot tell you to compute this, but I found it wise because when it comes to reality, it is the best way to evaluate a project. The next one is extended IRR, internal rate of return. We say that this is what we call the XIRR. We say that use the same steps as the IRR, but this time use the cash flows using considering the actual date that they occurred. Using the actual date that they occurred. So we are just taking the same argument, but here we are not taking the NPV, we are using the extended NPV. I just wanted to demonstrate that one. not necessarily because it will be tested in an exam, but to make you understand that there are better methods of evaluating the projects. The cash flows, use the cash flows, use the cash flows considering, use the same steps as IRR, but this time use the cash flows considering the actual date that they occurred. That is it. So when it comes to the real practice, the best method to use is the extended IRR, but when it comes to the examination, the examiner will test the NPV and the IRR. I don't know whether someone, I don't want you to ask many questions because I don't want to spend a lot of time on this one. I just want to continue. Yeah, someone this is that they get Coram B and D. Someone was asking about Coram B and D. Coram B. Okay, Coram B, I was just trying to give you the years. If you counted from January to that date, how many years are those? You take the months as a fraction. Yeah, that was a good question. Then use that one to discount the normal way we discount. Yeah, so I think that is it. And yeah. Let me not repeat the extended NPV. We will waste a lot of time. It's a retro-technical, and possibly you will not be tested in an exam. Yeah, so I just wanted to give you an overview so that when you go to practice and you ask a question, you will not be stranded and say that you have never had something like that. Yeah. Yeah, someone is asking whether I will share. I will share the Excel sheet. I will share the Excel sheet. Good. That is the issue to do with the discounted cash flow method or the method of evaluating the project viability. I want to explain something very important, and I will call it determining the cash flows for project evaluation. Determining cash flows for project evaluation. The examiner will not give you the cash flow the way I have given. The examiner will tell you to determine the cash flows. Which cash flows do we determine? Cash flow number one is the initial capital outlay. Initial capital outlay. Initial capital outlay. We say that this is the investment. This is the investment in the project. In the project, which is a cash outflow. Which is a cash outflow. I hope you can see my Word document. Please let me know whether you can see the Word document before I continue. Let me know whether you can see the Word document so that I may not give the wrong information. Okay, yeah, I can see people saying, yes, it is visible. Good, good, good. This is the investment in the project, which is a cash outflow. We say that in case the investment or part of the investment or part of the investment is incurred after year zero, Such cash flow, such cash outflow, outflow must be discounted, to the present value. In case there is any cash outflow that is incurred after year 0, such cash flows must be discounted to get the present value of the cash outflow of the cash outflow. And I want to demonstrate this one with an example. Let me give an example. We say that a 6 years project, a six years project require Rwandan francs 120 million in year zero, and an additional investment at the end of year 4 amounting to 45 million Rwandan francs. We are investing in year 0 and 20, but at the end of the 4th year, another 45 million is invested. So the question is, determine the initial capital if the cost of capital is 15%. When you have it like that, we say that here we have the years, year 1 and year 4. And then we have the initial capital, or let me call it investment. Here we have year 0, that is the investment is in year 0. This one, we invest like that, 120. This is an investment. Then in year 4, we are investing another 45 million. This is what we need to discount. We say the discounting factor. I want someone to give me the 1.15 power negative 0. Another one to give me 1.15 power negative 4. Let me have these ones so that at least we can get the invested capital, the present value of the capital invested. This one should give me a 1 equals 1. This one should give me, how much is 1.15 per negative 4? For negative 4, let me see. Oh, here someone says that I forgot to say at the end of year 4. I said at the end of year 4. Yes, that is correct. Thank you. Good. Let me see how much is it in 4 decimal places. 4 decimal places. 4 decimal places. 4 decimal places. 5717. It said 5717. 5717. I think this is what we have. Then, if that is the case, then we say that this is the present value cash outflow. This time is cash outflow. This is 120. How much is the other one? 45 million times 0.5717. Someone to give me? Someone to give me. Someone says 25,726. Can we confirm that? $25,726. 25,726 500. That's what I see. I think that is the correct thing. This what we call the total present value cash outflow. Present value cash outflow, and this one will give us from 145. 145, if I am correct. 145, yes. 145. That is the initial capital outlay. That's the first cash flow. Always determine the initial capital outlay. In most cases, you'll be told that it is just incurred once. But if they are incurred after year 0, always remember to discount. The next item, determine the annual cash. I want to give the, determine the annual cash flows. Determine the annual cash flows. Cash flow. Determine the annual cash flow. Like that. Determine the annual cash flow. We haven't taken even a break to take some water. So can you take some 10 minutes? You take some water or coffee, then we continue. Let's take a short break. Continue. You have taken enough of break. Yes. Let's get back. Let's start the last part of this lesson. Good. We've determined the initial capital outlay. That is very critical when it comes to the project evaluation. Determine the annual cash flows. In determining the annual cash flows, we need to get the revenue, or let me put it this way. We say that these are the cash flow that are realized annually during the project life. They are determined annually during the project life. When determining this one, let me see. I think I should give an illustration instead. I hope you can hear me. I hope you can see my screen. Can you first confirm that before I proceed? Can you hear me? Can you see my screen? Good. I see you can hear and you can see my screen. I need to avoid a scenario where I'm explaining and you cannot hear. Okay, good. So these are the cash flows that are realized annually during the project life. I want to explain this part using an example. Example. We say that, let me say this. I say that suppose the project above, suppose the project above is expected to generate the cash flows as follows. Is expected to generate revenue as follows. We say years. I'll give it 1, 2, 3, 4, 5, and 6. Revenue. This is in Rwandan francs, and my revenue is in millions, in thousands. Let me give it in thousands. We are talking of 120 million. So this one I can say that the first year is 56 million. The second year is 62 million. The third year, we said that it is 76 million. The fourth year, 78. The fifth year is 84. And the last year, it is generating 96 million. This is in revenue form. Oh, actually, I should have given a bigger figure. Let me give this way. Let me give it this way so that we can have it well. Like this, like that, like this, like that, like this. Yeah, good, that way. Then we are told that the initial capital, the capital incurred in year 0, in year 0 will be depreciated on a straight line basis with a salvage value of let me say 54 million at end of year 6, but year 4 investment will be amortized evenly with a nil salvage value, with a 0 salvage value. So that one will be amortized to 0, but the initial capital in year 0 will be depreciated with a salvage value of 54. We say that variable cost is 40% of revenue, and a fixed cost and annual fixed cost is 36 million. Yeah, like that. I will also say that tax rate is 30%. I've given the information that you would expect when determining the annual cash flows. So we are required to determine the annual cash flow. Determine the annual cash flow for each of the years. Determine the cash flow. Determine the annual cash flow. Determine the cash flows. Look at that illustration. 1 second, 1 minute, 1 minute. Look at it, so that I can explain. Look at it. I want us to work on it together. Look at it. 1 minute, 1 minute. I can see someone. I asked whether you could hear me. I hope the one who said you could not was before. Yeah, okay. Now, having looked at that illustration, I want us to work on it together. We see what is expected. Someone wants us to include working capital, but let's first work on it this way. So here I have my cash flows. I want us to work on it together, like that. Let's do the solution together. I want you to give me variable costs. Variable cost is 40%. Now, I need someone to give me this variable cost, because 40%, I get what we call the contribution. Or let me use an Excel sheet. Let me use an Excel sheet so that we can move fast. Make things easier. Just there we go. If you can see my screen, I am displaying an Excel sheet. Yeah, like that. This will help us to move very fast. I will say years 1, revenue. The only thing that I need to borrow is the revenue. Yeah, good. In fact, I should have just pasted here. I don't know why. Yeah, good. Like that. This is your 1, 2, 3, 4, 5, 6. Like that. Yeah, good, 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 good. I have the variable cost. The variable cost at 40%. So this is 40%. 40% multiplied by this, but I need to minus it like that. So I'll control here. This is contribution. The contribution. My contribution equal that is 6 like that. I'll put it like that. Then I'll call this one earnings before depreciation and tax. Earnings before depreciation and tax, which is equal to, we take the contribution minus depreciation. That gives me the earnings before depreciation and tax like that. I hope it is understandable from there. Earnings before depreciation. Here we have depreciation. The depreciation. We are told that the depreciation is equal to 120 minus 56. And because this one is evenly, we divide it. We divide by 6. Divide by 6 years. That way. But I can, okay, was it 56 or 54? I think it was 54. Let me go back to the question and check. Let me check from the question. We say that, yeah, the salvage value is 54. The salvage value is 54. Like that. Then we are told that there was amortization. Amortization. We are told that this investment is at the end of year 4. So year 5 and 6, we will take the 45 million, we divide by 2 because we are told that that one will have to be amortized evenly. So we will minus the amortization at that point, like that. The amortization and depreciation treated the same way. So this is the earnings before tax. Earnings before tax equals, we sum up these two like this, then we take it across that way. So we have the earnings before taxation. Then we go ahead and less tax at 30%. This is equal to 30% multiplied by this profit. Like that. This taxation. This will give us the accounting profit. Earnings after taxation. That's the accounting profit. This is what we call accounting profit. Or let me not put the word accounting profit. Just understand that that is it. So this is taxation. We are minusing tax. Oh yeah, I had put two negatives. This is equal to, you pick the earnings before taxation, you minus tax, like that way. Then at this point you add back. You add back depreciation, and you also add back amortization. You add back amortization. The depreciation is equal to, we had the depreciation here, and the amortization, we have to put them back like that, because we are looking for the cash flows. So this is annual cash flows. So we'll take the annual cash flow is equal to, we pick these ones, earnings after tax, add depreciation and amortization. This will give us the annual cash flows, like that. That is the way to go about it. If someone has a question, please ask a question, or if there is something that I have overlooked. Someone said that if you are the one who could have depreciated amortization in year 4, but we are told that the investment was done at the end of year 4. I don't know how you could have depreciated, and yet it was incurred at the end of year 4. We are told in the question, if you go back to the question, in the question we are told that, let me read through the question again. The capital incurred in year 0 will be depreciated on a straight line basis with a salvage value of 54 at the end of year 6. But year 4 investment will be amortized evenly with a 0 salvage value. When you go back to the question, the investment, when you go to where we started the question, the statement read, if I could read through it, initial investment, a 6-year project require 120 million in year 0 and an additional investment at the end of year 4. If it is at the end of year 4, how do you capture year 4 in the amortization? You cannot. It is the end of year 4. It is not the start of year 4. Neither is it the end of year 3. That is the greatest question that a majority are asking. I want to put this thing to the Word document so that at least we can move together. And let me put it back to the Word document. When you are revising, you will see it. I've just done what is in the question. I haven't exaggerated or changed anything. I've just done it the way it is in the question. Exactly the way it is in the question. So, good. That is the way to determine the annual cash flow. Unless someone has a question, I have tried to explain it based on the much of the information that you can get when it comes to the question. This part of amortization can bring a problem but I have given it the way it is. Let me see whether there is a question before I proceed to the next step. Good. I hope we are all together now. Let me see on the other end whether someone has a question. If that is correct, and assuming that my display is showing the Word document, I'm assuming that my display is showing the Word document. Please, if it is not showing the Word document, let me know. Let me know so that I can make sure that I display what is correct. Is it showing the Word document? Is it showing the Word document? Good. If it is visible from that end, the next cash flow that you determine is determine the terminal cash flow. Determine the terminal cash flow. Determine the terminal cash flows. We say that these are the cash flows. These are the cash flows realized at the end of the project life. Project life. These are the cash flows that are realized at the end of the project life. We say that in the above example, these cash flows are the salvage value of the project. So we say that terminal cash flow is equal to, at the end of the project life, we are told that 1 million is realized. That's how to get the annual cash flows with the kind of information that we have, the kind of the information that we have. The next thing, or the last item to determine, is determine the NPV. Determine the NPV. And I want us to determine the NPV together. I want to determine the NPV together. I have the years. My project has years 1, 2, 6 years. I will have cash flows. My first cash flow $43,620. $46,140, $52,020, $52,860, $62,130, And the last one is 67,170. Like that. Then the next item is discounting factor. Then the last one is the PV. PV. In year 6, there is salvage value still. There is a salvage value here. So in year 6, we can have two cash flows. I will have it this way. The annual cash flow, I will add the 54 million. 54 million, like that. This will give me how much? 121. I believe, I don't know whether 121 is correct. 170. I believe it is correct. We need the discounting factor, and the discounting rate, the one that we used to determine the NPV, the one that we used to determine, yeah, 15%. We are discounting at 15%. 15%. At 15%. So how much is 1.15 for each of the years? I want you to discount these cash flows at 15%. Give me the PV and the total present value. Total present value cash inflows will less initial capital, initial or less present value cash outflow coming at a discounting rate of 15%. At a discounting rate of 15%. Can you determine the cash flows? Then you give me the NPV. Very fast, very fast, very fast. I'm waiting for you. Look at the cash flows. I'm displaying them. Discount at 15% and give me the NPV. NPV. I'm waiting for the NPV. Very fast, work on it. Very fast, work on it. is the NPV. Someone is asking, why add the salvage value in year 6? It is the cash flow in year 6. It is a cash inflow in year 6. That is why I have added. Both of them are cash flows in year 6. Someone says present value cash inflow 245. Let me put it there. Total present value cash inflow. Did you say 245 like that? I believe that is what I have seen. Maybe someone can confirm. Confirm that. Someone gives an NPV of 99. An NPV of 99. There is some correlation there. Like that. If that is the case, then we can say that the NPV is viable. The project is viable. Is viable since NPV is positive. Good. That is it, and that is what would be expected of us. Unless someone has a question, I think I have explained, elaborated. The terminal cash flow, we only had salvage value. Someone is asking about terminal cash flow. We only had a salvage value of 54 million that will be realized at the end of the project life when the asset is disposed. There's someone who gave us an NPV of 44. I don't know. Can you confirm the NPV? Can you confirm the NPV? I want to share this. If there is, let's leave it at that for today. Let us leave it at that for today. We meet tomorrow. There is a lot to be covered. It is good that we also have next week. Yeah, so let's get the NPV. Let's end it there. Let us end it there. See you tomorrow. Have a great evening. We meet tomorrow. Today we've done so many things.